Alright, it's time to begin, everyone. Welcome to Evil Dojo. I've recorded something like 90 minutes worth of footage here. I spent a couple days implementing new features. At the end of this video, we're going to have the ability to completely customize the ability to fire bullets from given new enemies. The goblin that we created last time now fires bullets, but a lot of the code is hard-coded into the system at the moment. So we're going to extend our capabilities so that we can define bullet patterns via JSON configuration files, just the same way that we do for a lot of the other in-game assets. There's a lot of slow movement, so I'm going to speed this video up a bit. Right now, I am just playing around with the generator's configuration file. This essentially tells the game what enemies to spawn and when, how many of them, how often, how many in a group, how many times the generation should occur, and where on the screen they should actually spawn from, as well as how big they are. Here I defined bats to be coming from the right side of the screen, followed by eyeballs that are, I believe, 4 times as big as normal. No, they're just 2x. But as you can see, I can play with the offset for when they begin spawning. So we're able to kind of reduce the problem of deciding what enemies should appear and where to playing around with some numbers in a text file, which I think is really cool. Again, we're playing at 2x speed right now, but I decide to test out the first few minutes of the game given a certain configuration. At the end of the day, what is a game, right? Like, how is a game like Super Mario visualized from a perspective where enemies appear at certain points in a level, certain power-ups appear, certain blocks, certain gaps that you can fall into? In a similar fashion, that's what I'm aiming for here, because I don't yet have a clear vision of what the end product is going to look like, but I do know that there is a process to engineer something that feels really good, because even just for me, playing the game feels really good right now. And that's true given various configurations of enemies here. I decided to throw goblins in. Something like 2, I forget what I decide here. Yeah, about like a minute into the sequence, 2 minutes in. So about 2 minutes in, which is enough time to collect enough power-ups, given the bats and the eyeballs, that you can get enough power-ups so that you can handle more difficult things. The eyeballs require 4 HP damage, right? A knife by default fires 1 HP damage. If you catch the knife and get it to rotate, that's 2 damage. And then every additional level of rotation past that point earns you an additional damage, I believe. I forget if it's exponential or linear scaling, but the whole idea being that, the longer you play the game, the harder things get, the more power-ups that you need to acquire in order to tackle these things more easily. As it is, we don't really have a means to take care of the bullets ourselves, except other than just dodging them. So it adds an extra level of hecticness and pressure to the player. I decided to take some notes in the to-do file. Need to make sure data structures are properly cleaned up after game over. Power-up spawn positions are incorrect. I still have to fix that. I don't actually fix that in this video. But every so often you'll see things that you know you need to take care of, but they're not like immediately the most pressing thing to be taken care of. So some things can be left for later, and it's important as a developer, game designer, etc., to figure out how to take note of the work that you need to do while also prioritizing actually getting things done. Let's slow down here, just so you can see the game at like its native speed. It's pretty slow, but this might be by design because a lot is happening on the screen, and there is definitely a desirable ebb and flow to dodging things, killing enemies, collecting power-ups, navigating around things. One thing I am looking forward to putting in is destroyable objects so that we can kind of create custom pathways and architectures that the player might have to navigate through, kind of like in a similar fashion to the game Ikaruga. So in the configuration file, I'm playing around with the spacing of the goblins, as well as how frequently their bullets appear. And somewhere along the way, I realize I don't have any way to configure the bullets very easily. Everything at the moment is kind of hard-coded in. Let's speed up a little bit. I noticed that the goblins are not being removed properly, and it's because we're not tracking the frame after we get the game over. To begin with, we were tracking total frames, which is what we call frame counts. The frame count gets updated at the end of render frame, but at the moment in this video, the frame count represents the total frame count. So what we're going to do is actually add another variable to keep track of the frame as of a new game, while separating out the total frame count for how long the game has been running. As you can see, I locate frame count right away in the main, and we introduce total frame count and current frame count. So we're essentially refactoring by extending this to track another variable. It's a very simple and straightforward process. Since we have changed the variable as it exists in main, we have to go through every other file, bring it in as an extern, and every place that we're currently referencing frame count needs to be changed to total frame count. So now we're tracking total frame count just the same way as we were doing before, but now we actually have titled the variable name properly so as to distinguish it from what we're about to start tracking, which is current frame count. The goblins keep spawning because the game logic was written initially with only one frame count in mind. By going back and adding in current frame count, I can now use that as the basis for, at the beginning of a level, have an enemy spawn at frame count number 3600, which would be approximately 1 minute into the game. In the moment, I believe I have goblins spawning around minute 2. At onset, goblins are small enough that the player can't actually hit them with the default knife. It flies right over their head. That was a total accident. But as Bob Ross said, there are no mistakes, only happy accidents. And that was a happy accident. Just like discovering the the knife catching mechanic in the initial competition against a fellow IRC chatter.
Yes. Fuck you, Dark Mage, you cunt.
I noticed that something's off with the animation right away. I realized, oh, it's still referencing the original frame count. So it was jittering because it was basically reading a garbage variable. Changing it to a current frame count fixes, or in that case, it was total frame count. But in this case, we only need current. All right, so now we got our frames correctly being tracked. And I decide I'm going to play the game for a little bit. The video here is recorded at 30 FPS, but the game does run at a full 60. It looks a lot smoother on 2x, probably for this reason. As you can see, like I said earlier, the default knife just flew right over the goblin's head, but because I've already picked up the spread power-up, I was able to actually hit one of them. I currently have these guys spawning in like a batch of, I think, 10. I'm not sure because I died there. So we got the double knife power up, so we're kicking some kind of ass. Goblin should be coming up. $10 seconds. I think they're at 3,600. Yeah. So the goblins are currently firing bullets at the player. At the time of bullet firing, the code takes a look at the player's current XY, and it draws a beeline between the goblin and the player and sends a bullet along that trajectory, right? Thinking out loud now, the player needs a way to survive these bullets if he happens to get stuck. A power up that affects as a shield would be kind of useful. There could be a weak shield that degrades every time you get hit. That could be upgraded to a stronger shield that doesn't get destroyed when hit, or something like that. Implementing that could be kind of fun, and also make for creating some more challenging enemies as well. I'm looking forward to implementing the first boss. There seems to be a desire for actual levels amongst people interested in the game. Because right now it's kind of like just a infinite shooter, but based off the way that the generator system works, we should be able to create levels pretty easily by also applying the same JSON configuration techniques to our backgrounds. Then we can start scripting out scenes where each scene is effectively a level. I don't think there's going to be a traditional title screen. There's definitely not going to be like a... Well, there will be, a continue functionality so that people can try to beat the game. But at the end of the day, the challenge is always going to be trying to beat it on one life, right? As is tradition. So I'm making the commit for total frame count now. We're merging it into main, or master rather, because fuck all that SJW nonsense. Like, I actually try to go out of my way. I've not done it for a couple repos, but most of the time I do go out of my way to rename main to master, because I think that shit is silly. Don't cancel me, bros and gals. So here's our configuration file. Bats, eyeballs, goblins, right? I'm playing around with a couple variables. Just testing out some counts. This is essentially one step towards that whole level idea. We play around with the frequency of the goblins, the number of bats that we actually see. See how far in are we? Oh yeah, we're still pretty early. Alright, so that could essentially be like level 1 right there. I don't know how much more we would want to shove into a first level, or how to create the best feeling experience for a player, or how to tune that level in such a way as to have like easy, medium, and hard difficulties. But these things are all now possible due to the tuning system. So now I'm debugging on the goblins, playing around with their bullets in code. I notice that this is pretty intense, but also passable if you don't have an infinite wave of goblins. So now I realize, wait a second. Now I realize that we need to actually have configurations for bullets. Because at the moment, everything is hard-coded in, but like I said at the beginning of this video, by the end of it, we're going to have a JSON configuration set up for bullets. All right. Go ahead and do my setup. This is the beginning of another recording. I've aggregated the videos together to try and give the best experience to you, the viewer. All right, so I'm testing the game out again. Catch the knife, throw a knife, game over. The difficulty definitely varies based off what power-ups you pick up. Because everything's random in the moment, it kind of gives that, perception of randomness. I should say, because everything is random, it gives the perception that every time you play the game, you're going to get a new experience, which is true. You might have a better run than another. And that's one thing I want to maintain is the procedural nature of this. So we are doing all right here. We've got the spread, but no additional knives. So it's just kind of like, the knives will have a bit of an upward curve or something to this effect. Like I said, I have no way to block the bullets at the moment. We're going to have to introduce a power up for that kind of thing. So update entity special actions is what actually does the bullet firing at the moment in our update file. So over in spawn, we have a spawn goblin bullet that I'm going to jump to in a moment. There we are. It's pretty straightforward, and it gets called over an update. See, current frame count mod 30. So the 30 is going to get pulled out into its own parameter. I'm about to take some notes on that. Okay, so we got a big goblin for testing purposes there. See, now I play around with the bullet firing rate. That's what I call the bullet frequency. I take some notes. Go and pull it out into its own variable. And that's one step forward. We also introduce a static bullet count. This is probably not the best way to go about doing this, but it works to begin with. So bullet count minus minus. So we have a running bullet count that we're decrementing that's static in memory. So once it's initialized, we can keep using it. Once it hits 0, we reset it to 5. Actually, I kind of flounder around like a bit for here because I'm trying to get it so that like there's a pause in between like rounds. Like at first there's like a spacing between each bullet, right? But then you have waves of bullets, so there's spacing between each wave. This can be measured in frames. So that's what I step towards. We get it to pop off 5 bullets before it stops. And we define a constant starting count that we can reinitialize to once the initial wave completes. We don't quite have it yet, but now we want to track whether or not the bullet system is firing or not. Copilot does a good job of trying to help out. But at the end of the day, I think this is what ended up working. No, we still have a little bit. Okay, so once the bullet count reaches, now we actually have real rounds. So you get fire 5 bullets and then wait for an equivalent amount of time and then fire 5 more bullets. And that way you've got a nice little gap in between each round that the player can actually run through. Look at that. It's pretty nice. Oh, I froze up there. All right, time to commit the code. So now we have bullet frequency as a concept step towards, but we haven't actually began the process of doing bullet configuration. Now we will. I'm going to take a little break here. Okay, time to define some bullet configuration. Create a new JSON file called enemy bullets. Just like a lot of the other JSON files, it's going to consist of an array of dictionaries, each one representing a different definition. We start off by creating a new enum as well as a struct representing enemy bullet movements and enemy bullet definitions. Copilot tried to generate something real fun there. So a bullet definition consists of a enum representing the movement, as well as integers representing speed, frequency, cooldown, and a double scale. Very similar to how we handle enemy and entity generation in general. So over in load.cpp, we create a new function called load enemy bullet definitions. It's handled very similar to a lot of the other functions in this file. We loop through our JSON array and check each object to make sure that they contain the proper keys and the values that are stored on those keys are of the correct data type. In JSON, I believe there's 3 primary data types. It's string, integer, and float, or double. So we are still writing code to handle parsing it properly. Doing this is a little annoying in C++, not gonna lie. Something like Python is a little bit better for this sort of thing. But at the end of the day, because the game is C++, and C++ is very fast once you actually have a program built and running. And with the help of Copilot, writing it is a lot faster now. So we are ripping out all the stuff from the JSON and adding a new enemy bullet definition to a map that we're keeping track of. Right there. Unordered map, string to enemy bullet definition. So given a particular key, we can get a definition on the pattern that that enemy should be firing bullets. This allows us to have multiple definitions for different enemies so that each one can have their own custom bullet patterns. Get the mic up in my face. All right, so just like all of the other data structures, we have to have a way to clean up the map when we're done using it. And we want to make sure that we call that when the game is over and we need to actually clean up everything. Just proper memory management. Let's see. I'm getting stuck. Oh yeah, no, we're about to make sure to call that function, load enemy bullets, or load enemy bullet definitions rather. And we only need to call it once because once it's loaded, we don't have to worry about reloading it on game over because it's not actually cleaned up until the user quits the game or the game closes for some reason. Let's see. We add enemy type to the bullet definition so that we can actually switch the map over from using a string lookup so we add the type to the structure, and now the map is going to, instead of using a string, it's going to use enemy type. And this should attain a subtle speed gain in terms of lookups. clear out the cache files and rebuild everything to make sure that everything is all good. Then I noticed enemy bullets was missing the correct type name. So the first time we do this, it's for the goblin. And we actually define another movement pattern called towards player, since that's neither up, down, left, or right. Because yeah, we have the cardinal directions, but in terms of direction as a vector, and we'll be able to get really complicated later by attaching vectors that can be updated for the bullets. I mean, they can be updated now, but like in a similar fashion to how like Toho script exists, right? It'd be interesting to be able to set the bullets up in a way that they can pivot mid-fire. That would be pretty crazy. So over in Spawn Goblin Bullet, we're making cases for the different movement types that we can have, so that way we can switch between firing upward and firing towards the player via the JSON configuration file. So the time between bullets there is pretty small. Frequency 1 means fired once every frame, or every other frame or so. We begin the process of moving hard-coded values away from Spawn Goblin Bullet and instead replace them with references to the enemy bullet definition that gets read in from the JSON file. This is how we actually connect the process of scripting out bullet definitions from JSON file and getting the result directly into the game. As I said at the beginning of this video, by the end of it, we would have the ability to script out enemy bullet definitions via JSON file. And here we are. We change cooldown to count, because that's effectively the same thing here. Speed, frequency, count, and scale, and movement. Currently, that's what we need to define enemy bullets. Look at that. That was pretty intense. Let's set it up so that it's one bullet every 60 seconds. Notice that spread. Make them move a lot faster now. That's a lot more reasonable. Speed 4, frequency 60. It's not bad to start with, huh? So if we, and look at that, straight up. So we're definitely giving the player something to dodge. So bullet star count is currently hard-coded to N here. So we're going to replace bullet start count. Or rather, we move it inside of the case, because it's going to be on a per enemy basis, right? So we pull in the count from the definition for the goblin if the enemy type for the ID is goblin. We move this code directly into a handled goblin bullets, anticipating that we're going to need similar functions for other enemies. Passing in the ID of the goblin. That way each one can have its own bullet count. That's pretty good. Fires pretty fast there. Still dodgeable though because of the frequency. We take a look at the code that we've written in preparation for a commit. And actually we are at the end of the video. And let's see how much more time is on here. Oh yeah, we're basically there. We go ahead and merge the code over into a master, delete the old branch, and we're done. I want to thank y'all for joining me. If you haven't done so yet, please like, subscribe, turn on notifications. I'm doing this pretty regularly if y'all haven't noticed. We've got 15 parts in this series already. There's still a lot to do. So I thank you for joining me today. Expect to see more soon. Until next time, friends. Take it easy. Evil Dojo. Out.